Imagine waking up one morning. You ask your AI assistant to plan your entire day. It books your meetings, answers every email, writes software, discovers a new medicine, negotiates business deals, designs a new product, and even makes scientific discoveries. Not because it was programmed for each task, but because it truly understands them. This isn't science fiction. It's the idea behind something researchers call artificial general intelligence, or simply AGI. Unlike today's AI systems, which are designed to perform specific tasks exceptionally well, AGI would be capable of learning, reasoning, adapting, and solving problems across almost any domain, much like a human, and perhaps one day even beyond human capability. For decades, AGI existed only in research papers and futuristic movies. But today, the conversation has changed. The world's biggest technology companies are investing billions of dollars into artificial intelligence. OpenAI, Google DeepMind, Anthropic, Meta, xAI, Microsoft, Amazon. Each is building more powerful models at an incredible pace. Every few months, AI seems to cross another milestone that once looked impossible. It can write books, generate realistic videos, solve complex mathematical problems, write production quality code, translate languages instantly, create music, analyze scientific research, and in some cases, even outperform experts on standardized benchmarks. This rapid progress has sparked one of the biggest questions in technology. Could AGI actually arrive before 2030? Some researchers believe it could happen much sooner than most people expect. Others argue that we're still decades away. The truth is, nobody knows for certain. But one thing is clear. The race has already begun. And the outcome could reshape the future of humanity forever. In this documentary, we'll explore what AGI really is, why so many experts believe it could become reality within this decade, the enormous technical challenges still standing in the way, which companies are leading the race, and what a world with AGI might actually look like. Because if AGI arrives before 2030, it may become the most important technological breakthrough in human history. Artificial intelligence didn't begin with ChatGPT. In fact, the dream of building intelligent machines is more than 70 years old. Back in the 1950s, scientists believed creating human-level intelligence might only take a few decades. But reality turned out to be far more complicated. Early AI systems could only follow fixed rules. They couldn't learn. They couldn't adapt. And they certainly couldn't understand the world like humans do. As a result, progress slowed dramatically. The excitement faded. Funding disappeared. And the industry entered what became known as the AI winter. For years, many people believed artificial intelligence had failed. But behind the scenes, researchers kept working. Computers became faster. The internet created an explosion of data. And graphics processors, originally designed for video games, suddenly became powerful enough to train enormous neural networks. Then, everything changed. Deep learning arrived. Instead of writing thousands of rules by hand, engineers began training neural networks using massive amounts of data. The results shocked the world. AI started recognizing faces, understanding speech, translating languages, and beating world champions in complex games. Yet these systems still had an important limitation. Each AI could perform only one specific task. One model translated languages. Another recognized images. Another played chess. None of them could do everything. Then came foundation models. Instead of training AI for just one task, Researchers built massive models capable of learning general patterns from enormous amounts of information. The breakthrough accelerated dramatically with large language models. Suddenly, people could ask questions in natural language, write essays, generate computer code, summarize books, analyze documents, and hold conversations that felt surprisingly human. The AI race exploded. OpenAI introduced ChatGPT. Google accelerated its AI strategy. Anthropic released Claude. Meta opened powerful AI models to developers. XAI entered the competition. Every few months, a new model arrived that seemed faster, smarter, and more capable than the last. But despite these incredible advances, today's AI still has clear limitations. It can make mistakes, invent facts, forget context, struggle with long-term planning, and often lacks genuine understanding of the real world. Which brings us to the biggest question of all. If today's AI is already this powerful, what exactly separates it from true artificial general intelligence at first glance? Today's AI already seems incredibly intelligent. It can write code, compose music, create stunning images, generate realistic videos, and answer questions in seconds. So, if AI can already do all of this, why do researchers keep saying we haven't reached AGI? The answer lies in one simple word: generalization. Today's AI is powerful, but it's still narrow. It performs exceptionally well within the tasks it has learned. Yet when faced with completely new situations, its weaknesses become clear. Imagine asking today's AI to design a revolutionary scientific experiment, build the laboratory, raise funding, lead a research team, adapt when something unexpected happens, and continue improving for years without human guidance. That's an entirely different challenge. Humans can transfer knowledge from one field to another. A doctor can learn programming. An engineer can study economics. A scientist can become an entrepreneur. We constantly learn new skills without starting from zero. This flexibility is one of the defining characteristics of human intelligence. AGI aims to achieve something similar. Instead of mastering one task, an AGI system would be able to learn almost any intellectual task. It could reason through unfamiliar problems, adapt to changing environments, plan months or even years ahead, combine knowledge from multiple fields, and improve itself through experience. Another key difference is common sense. Humans naturally understand countless everyday concepts. We know that glass breaks when dropped. Ice melts in the sun. A child eventually grows into an adult. Most current AI systems don't truly understand these relationships. They recognize patterns from data, but they don't experience the physical world the way humans do. Researchers often describe this as the gap between prediction and understanding. Closing that gap may be one of the greatest scientific challenges of our time. This is why many experts believe AGI isn't simply a larger version of today's AI. It may require entirely new breakthroughs in reasoning, memory, planning, learning, and perhaps even new computing architectures. The question is no longer whether AI will become more capable. It almost certainly will. The real question is, how close are we to crossing the line between powerful software and genuine general intelligence? If AGI becomes reality, it won't just be another software update. It could become the most valuable technology ever created. That's why the world's biggest technology companies are investing tens of billions of dollars into artificial intelligence. But who is actually leading the race? Let's begin with OpenAI. The company transformed public perception of AI with ChatGPT. What started as a research organization quickly became one of the most influential AI companies in the world. With each new language models, OpenAI has pushed the boundaries of reasoning, coding, creativity, and multimodal intelligence. Its long-term mission remains ambitious: to build artificial general intelligence that benefits humanity. Next comes Google DeepMind. Long before generative AI became mainstream, DeepMind was already achieving remarkable breakthroughs. Its systems mastered complex strategy games, advanced scientific research, and developed powerful reasoning techniques. Many experts believe Google possesses some of the world's strongest AI research talent, along with enormous computing infrastructure. Then there's Anthropic. Founded by former OpenAI researchers, the company focuses heavily on AI safety and alignment. Instead of only building more powerful models, Anthropic is trying to ensure future AI systems remain reliable, transparent, and controllable. Its Claude models have quickly become some of the strongest competitors in the industry. Meta has chosen a different strategy. Rather than keeping every breakthrough behind closed doors, it has released several powerful open-weight AI models. This approach allows researchers and developers around the world to improve AI much faster. Some believe open models could dramatically accelerate progress toward AGI. Another major competitor is xAI. Founded by Elon Musk, the company's goal is to better understand the universe through artificial intelligence. Although newer than many rivals, xAI has expanded rapidly by combining massive computing resources with aggressive research. And these aren't the only players. Microsoft continues investing heavily in AI infrastructure. Amazon is building enormous cloud computing capabilities. NVIDIA supplies many of the advanced chips powering today's AI revolution. Every major technology company understands one thing: the first organization to achieve AGI could reshape industries, scientific research, national security, and the global economy itself. But despite all this progress, building AGI isn't simply about spending more money or training bigger models. Some of the hardest challenges still remain unsolved from the outside. It might seem like AGI is only a few software updates away. After all, every few months, AI appears smarter than ever. But behind the scenes, researchers know the journey is far more complicated. One of the biggest obstacles is reasoning. Today's AI can generate convincing answers. But true reasoning means solving completely new problems, connecting ideas, questioning assumptions, and finding solutions without relying only on patterns it has seen before. Humans do this naturally. Machines still struggle. The second challenge is memory. Current AI models can remember conversations for only a limited period. Humans, on the other hand, build knowledge over an entire lifetime. We remember experiences, learn from mistakes, and continuously improve our understanding of the world. For AGI to become reality, it may need a much more persistent and reliable form of long-term memory. Another enormous challenge is the physical world. Humans don't learn only by reading text. We learn by seeing, touching, walking, building, and interacting with our environment. Many researchers believe future AGI systems may need to combine language, vision, audio, robotics, and real-world experience into one unified intelligence. Then comes computing power. Training today's most advanced AI models already requires gigantic data centers, thousands of specialized AI chips, and enormous amounts of electricity. Each new generation demands even more computational resources. Some experts believe future AGI systems could require computing power many times greater than what exists today. But perhaps the greatest challenge of all is safety. What happens if an extremely intelligent AI begins making decisions humans don't fully understand? How do we ensure it follows human values? How do we prevent misuse? How do we build systems that remain helpful, reliable, and controllable, even as they become more capable? These questions have become some of the most important topics in AI research. Because creating a powerful intelligence may actually be easier than ensuring it always acts safely. The race toward AGI is no longer just about building smarter machines. It's about building intelligence that humanity can truly trust. Imagine. It's the year 2030. Artificial general intelligence is no longer a theory. It's a reality. How would the world change? The first transformation could happen in healthcare. An AGI system might analyze millions of medical records, scientific papers, and genetic datasets within minutes. Instead of taking years to discover new medicines, life-saving treatments could potentially be developed much faster. Doctors wouldn't disappear, but they could gain an incredibly powerful partner. Next comes education. Imagine every student having a personal AI tutor. One that understands their strengths, recognizes their weaknesses, adapts every lesson, answers every question, and never gets tired. Learning could become more personalized than ever before. Scientific research could also accelerate dramatically. Many of today's greatest challenges, from clean energy to climate modeling to new materials, require solving problems too complex for humans alone. AGI could simulate millions of possibilities, identify hidden patterns, and help researchers reach discoveries much faster. Then there's robotics. Today's robots are excellent at repetitive tasks, but they struggle in unpredictable environments. An AGI-powered robot could learn new skills, adapt to changing situations, and safely work alongside humans in homes, factories, hospitals, and disaster zones. Businesses would change as well. Routine office work, customer support, data analysis, software development, financial planning, marketing, even product design could become dramatically more efficient. But AGI wouldn't simply automate jobs. It could also create entirely new industries, new professions, and opportunities that don't even exist today. History has shown that every major technological revolution creates disruption, but it also creates new possibilities. The internet changed communication. Smartphones changed daily life. Artificial intelligence is already changing how we work. AGI could change almost everything, which is exactly why so many governments, companies, and researchers are racing to prepare for a future that may arrive much sooner than expected. Every revolutionary technology has changed the world. Electricity, the internet, smartphones, all created incredible opportunities. But they also introduced new challenges. Artificial general intelligence may be no different. In fact, its risks could be unlike anything humanity has faced before. The first concern is misinformation. Today's AI can already generate realistic text, images, audio, and even videos. As these systems become more capable, distinguishing between real and fake information could become increasingly difficult. This raises serious questions about trust, media, and public opinion. The second concern is cybersecurity. An AGI system might help defend digital infrastructure by detecting attacks in seconds. But if it fell into the wrong hands, the same intelligence could potentially be used to discover software vulnerabilities, automate sophisticated cyber attacks, or create highly convincing scams at an unprecedented scale. The outcome will depend not only on the technology, but on how responsibly it is developed and used. Then comes the economy. Many experts believe AI will automate more routine tasks over time. History suggests that technological progress often replaces some jobs while creating entire, but the transition can still be difficult. Workers may need to learn new skills. Businesses may need to adapt. And governments may face important policy decisions. Another major challenge is governance. If AGI becomes as powerful as many researchers expect, who should decide how it is used? Technology companies? Governments? International organizations? Or should there be global rules that apply to everyone? There are no easy answers. Perhaps the biggest concern discussed by researchers is alignment. In simple terms, how do we make sure an extremely capable AI continues pursuing human goals, even as it becomes more intelligent? This question has become one of the most important areas of AI research. Because creating intelligence is only half the challenge. Ensuring that intelligence remains beneficial could determine whether AGI becomes humanity's greatest achievement or one of its greatest mistakes. The decisions being made today may shape the future for generations to come. For decades, artificial general intelligence was considered a distant dream, something our grandchildren might one day experience. But today, that timeline is being questioned. Every year, AI models become faster, smarter, more efficient, and more capable. Tasks that once required teams of experts can now be completed by a single AI system in minutes. This rapid progress has divided the AI community. Some researchers believe AGI could arrive before the end of this decade. Their argument is simple. Computing power continues to grow. AI chips become more powerful every year. Training methods continue to improve. And companies are investing tens of billions of dollars into AI research. From this perspective, AGI isn't a question of if. It's a question of when. But not everyone agrees. Many scientists argue that today's AI still lacks genuine understanding. It predicts. It imitates. It recognizes patterns. But true intelligence may require breakthroughs we haven't discovered yet. Some compare the situation to aviation. Building a faster car doesn't eventually create an airplane. At some point, a completely different breakthrough becomes necessary. The same could be true for AGI. Scaling today's systems may not be enough. New architectures, better reasoning, long-term memory, embodied learning, or entirely new scientific discoveries may still be required. And then there's another possibility. Perhaps AGI won't arrive all at once. Instead, it may emerge gradually. Each new generation of AI becoming slightly more capable. Until one day, we realize we've quietly crossed the line. No dramatic announcement. No single breakthrough. Just a slow transformation. That changes everything. So, could AGI arrive before 2030? The honest answer is nobody knows. But one thing is undeniable. The pace of AI progress is accelerating. And the next few years may become the most important period in the history of artificial intelligence. Let's step back for a moment. Only a few years ago, most people had never used an AI chatbot. Today, millions of people rely on artificial intelligence every single day. Students use it to learn. Programmers use it to write code. Doctors use it to analyze medical information. Businesses use it to improve productivity. And researchers use it to accelerate scientific discovery. The speed of progress has surprised almost everyone. But history teaches us an important lesson. Every technological revolution begins slowly, then suddenly changes everything. The internet looked like a small experiment. Smartphones were once considered unnecessary. Cloud computing was dismissed by many companies. Yet today, It's difficult to imagine life without them. Artificial intelligence may be following a similar path. Whether AGI arrives before 2030 or much later, the direction is clear. AI systems are becoming more capable every year. Companies continue investing billions of dollars. Governments are creating new AI strategies. Universities are producing groundbreaking research. And competition is accelerating across the world. The question is no longer whether AI will transform society. It already has. The real question is, how far can it go? Will AI remain an incredibly powerful tool? Or will it eventually become a true general intelligence capable of learning almost anything? No one has the answer. Not even the world's leading researchers. But one thing is certain. The next decade may become one of the most important periods in the history of technology. And the decisions made during these years could shape the future of humanity for generations. Perhaps the biggest mistake we can make is assuming that AGI is simply another technology. It isn't. If artificial general intelligence becomes a reality, it could influence nearly every part of human civilization. Healthcare, education, scientific discovery, space exploration, manufacturing, finance, transportation, and even the way governments make decisions. But with extraordinary power comes extraordinary responsibility. The future of AGI won't be determined by technology alone. It will also depend on the choices made by researchers, engineers, governments, businesses, and society itself. Will we build AI that expands human potential? Or will we struggle to keep pace with the intelligence we've created? No one knows the answer today. And that's exactly what makes this one of the most fascinating stories of our time. Whether AGI arrives before 2030 or decades from now, one thing is becoming increasingly clear. Artificial intelligence is no longer just changing computers. It's changing the future of humanity. The race has already begun. The investments are growing. The breakthroughs are accelerating. And every year, the impossible starts looking a little more possible. So the question isn't just, could AGI arrive before 2030? The bigger question is, are we ready if it does? Thank you for watching. If you enjoyed this documentary and want more deep dives into artificial intelligence, emerging technologies, geopolitics, and the future of our world, subscribe to Oracle Alpha. Because the future isn't waiting. And neither are we.